Good day, ladies and gentlemen, and welcome to Automation Works. Not just to see what Automation Works can do for you, but what Automation Works can do for your future, your children's future, and the future of the world. My name is Paul Odendal. I am a second year Term 4 student here at Automation Works. And through the year, we have done 4 different terms. Term 1, Mechanical Engineering, which was designing my BattleBot for my club. Term 2 was Arduino, where I wired up my robot and gave her coding. Term 3 was Industrial Automation, where I've designed a chicken egg incubator. And then Term 4 was Python coding, which I'll be presenting to you today. Now I will show you quickly my demonstration. My project is a petrol sensor, but for the moment I'll be demonstrating you on water. Here you can see the ID, the tank's level at the moment, the time and the date. And as you could look closely here, you can see it is accurate to it. It's somewhere around the 4.5 mark. More to the 5 mark than the 4.5 mark. And as I slowly tap out the water, it should go down. Back to my spot. All right, where was I now? Problem. All right, problem identification and motivation. Now I have noticed that my father, who is a farmer, and similar farmers around South Africa lacks the time to physically go check on their petrol tanks to check the gauge, to check how much fuel is being used at what specific time. So then, my problem statement was to develop a mobile app that is integrated with an ultrasonic sensor and with an A9 GSM prototype board with an antenna and a server to monitor fuel levels in stationary fuel tanks remotely. It will then track fuel usage more precisely, save time, and monitor fuel consumption more efficiently. Now then, solution process. Like I said, I have lived on a farm with 2 stationary fuel tanks. The gauges are often exposed to spider webs or muck, and thanks to years of being in the rain, usually covered in rust, which usually gives inaccurate readings when reading on the fuel gauge. As you could see, I'm using a magnifying glass trying to see what stands on there, which is a very hard situation. So I was then later approached by a close friend of mine, or a close friend of my father's, to develop an app which will calculate the gauge, which will be like an app, a digital gauge. He did not want any more this, hardware petrol gauge. He wanted a digital gauge for displaying and recording his fuel usage more properly. Now then, real-world applications. My product can be used on small farms with multiple petrol tanks that are spread out all over the farm. It will take a huge amount of time to go to each petrol tank and to check their gauges Or another place where it could be used is by sending the fuel tank levels to a farmer, to his app, when he's not on the farm. For an example, Mr. Piet Schoenman, one of the world's biggest tabakboerdery in Oudtshoorn, who is the owner of 6 different farms. And to check each one's fuel tank, he needs then to drive to each fuel tank, and those farms are spread far and wide between. So going to those fuel tanks will just cost a lot of time and a lot of money. My app will then help him by displaying the different levels of each fuel tank he has in his possession. Now the demonstration of my technical understanding of my product. An ultrasonic sensor will be attached to the fuel tank, this blinking button up here, which will then send Yeah, sorry. An ultrasonic sensor up here will determine the level of the water tank, which will then send a signal to the A9 GSM finger board, which will then calculate what is the water level, what is the date and time, and then send it to a send it to a server or MQTT broker where the data will be stored. And then last but not least, the app will then read that data from the server and then display it on an app for the client. Here you can see my flow chart. Now firstly, you'll need to log in with the right credentials, otherwise you'll get an error sign. It will then send you to the main page. Now, and the main page will be then requesting data from the server that was sent by the A9 Finker GSM prototype board, which got its information from the ultrasonic sensor. And there was a history page which you can click, which will send you to the history page, which will request previous data on the server, and it will display in the history of the petrol usage so that you can see what amount of petrol used and how much and what time. Now then, innovations. What makes my product unique is it can be fitted on any type of petrol tank as long as the right measurements are put in place. And the farmer can access that information anywhere in the world as long as it have cell phone signal. Now then, here you can see my hand sketches. We firstly needed to draw and design how our app is going to look. I have the login page, the main page, and my history page. Here you can see code examples, main page. Firstly, we have libraries to help me code better. We have then positions of the labels, what the labels need to do or say, and then the execution of the code. Had ek nou te vinnig? Sorry, technical problem. There we are. And here you can see how my app looks. We have the login page, username, password, ID, and if everything's correct, you log in, it will take you to the main page where the topic I have subscribed to the broker or server is located here with the tank level and the time and the date. And here is the wiring diagram for my device. We have the ultrasonic sensor and the A9 board here. The A9 board has a SIM card in it that connects it to a cell phone signal and will then send the information via MQTT broker from this board to the main server, where the data is stored. Alternative considerations. One of the options for an alternative consideration is the farmer can be day and night positioned at the fuel tank to see firsthand how much fuel is being used. As you can see, it's not very good. Or option two, the option one is the farmer can manually check it, which is time consuming, or the farmer can have someone stationed there 24/7 to log every time the fuel drops, which is money consuming or expensive, because you need to then pay the farmer, the worker there that stands and constantly catalog the fuel levels. Product testing. I have focused primarily on the software aspects instead of the hardware aspects, because when it comes to coding between liquid, it is just a few lines of change, because to an ultrasonic sensor, liquid is liquid, no matter if it's water or combustible. And I have decided to use a water tank because it is much safer for you people when I test it. But rest assured, in the future, the testing on a petrol tank will be done. Then I tested for data sending via MQTT brokers, and the data sent was successfully transferred via the A9 GSM prototype board to the server broker. Tools used. I've mostly used software tools and Python ID, which was PyCharm and Phony, and I used a couple of Python libraries like Tinker, MQTT, and Time. And then I used a server where the data is stored. Skills learned. Firstly, I learned how to code in Python. I learned patience because this code has crashed 22 times and you needed to learn patience, otherwise you would have smashed your laptop in. I learned critical thinking. Every time the program crashed, I needed to critically think, how can I fix this problem? And by doing that, I have learned debugging, fault finding, and working with errors. And another thing I've learned this term was better time management. Now then, assembly sequence. Firstly, I needed to plan and write down how my code's going to look. You've seen the hand sketches. Then draw the wiring diagram for the sensor. Wire up the ultrasonic sensor to the A9 GSM prototype board and then test. Write the code. Write the code for the board and test. Integrate a server to my design and test. Many tests. And then last but not least, write the code for the app what the client is going to be using to display data. Now the research and information. I have collected many forms of information and discovered that my project already exists, but they are few and far between and are very rare in places like South Africa. Another thing I needed to research is how liquid can be measured. And I needed to research how data can be sent over long distances. And I needed to research how that data can be displayed in an app. Now then, through my research, I have discovered that an ultrasonic sensor is the best form of liquid sensor for effectiveness, accurate results. I have then learned to use an MQTT broker to send data because it was the best for cost effectiveness. And then I used Tinker for app display because it was the easiest use and the quickest to use. Because I did have limited time, only 4 weeks to complete this app. Here you can see my activity log. Firstly, we had theory, the work we needed to learn for this term, design tutorial project, a project given to us by the teachers to show us that we understand the work. We had PPD, our personal professional development provided by Mr. JC. We had a little bit of work here at Automation Works, where we were working next door as unpaid interns, and then my design project, the project I am now showing you. Now then, I firstly, sorry, a flattering image is not JC. Most impactful PPD was each week Mr. Umjashi provided us with subjects and a subject to research. He provided us the research papers, but they were faulty, and we needed then to point out which one was wrong and why. Another thing that I found interesting was altruism. Primarily the difference between impure and pure altruism. Now, altruism, what does that mean? It is the idea of doing something for someone and not expecting anything in between. And another thing that I found most interesting was that positivity and cheerfulness can make a person extremely attractive. In other words, I must be very, very, very handsome. Technical difficulties. Firstly, I needed to find a petrol tank to test on, and then finding the right sensor, which was ATX, Hazardous Explosive Atmosphere Regulation, approved. Then technical successes. I have then decided to switch out the petrol tank for a water tank for this demonstration, primarily for your safety. And then I switched the switched the petrol sensor for an ultrasonic sensor for cost effectiveness for this lovely demo. Now then, lessons learned. Firstly, I learned how to work with Python coding, PyCharm, PyTinker, and the Python Tinker libraries. And then I learned that ultrasonic sensors can actually measure liquid, which I had no idea is possible. Now then, future improvements. Firstly, the code will be refined so that it will work more smoothly and better. The ultrasonic sensor will be replaced by an ATEX approved ultrasonic sensor so that the product doesn't explode the farmer's petrol tanks. I will then test it on a fuel tank, add a history page with an Excel display so that you can see the history of your fuel tank, and I will add an alarm to tell you when it's time to refill your petrol tank. Now then, here you can see my bill of materials and time spent on the design project. Here's all the items which was lovely provided by Automation Works, the cost, the amount, and total cost, and then time spent on the design project. I have a total of 137 hours, and the amount of days were 20 days. Now the demonstration of design project, which I have already shown you. And acknowledgement. Firstly, I'd like to thank Mr. JC, our PPD instructor, Personal Professional Development instructor, for teaching me things like altruism and how you act influence on how people see you. I'd like to thank Ms. Tani Elmery, our coordinator and timekeeper, for keeping us all up to date and scheduling everything that needs to happen in the class. I would like to thank Mr. Desmond, a close friend of my father, for providing me with this design project. And most of all, I'd like to thank Nick for helping me learn Python, improve my design, and not giving up on me, even though I have asked the same question 22 times. He has the bruises to show for it. And now here is my design project poster, my problem statement, motivation, a lovely QR code which will take you directly to my website where there's more information about me and my design project and contact information about me. Now then, ladies and gentlemen, last thing I wish to ask is who is interested? Thank you.
Very interesting.
Yes, first client. Any comments or questions, good or bad? Welcome.